This is a circuit diagram of a series circuit. And this circuit has one resistor and 3 LEDs, light emitting diodes. The resistor is in place because we have to limit the current through an LED, otherwise the LED will fry. The definition of a series circuit is that all of the components have the same circuit path, or in other words, all of the current must go through each component. And the point of this video is to show you that the current is the same everywhere in a series circuit. Whether you measure current right here between L1 and R1, or between these two, or here, or down here, the electron flow, or the current, is the same everywhere. In order to measure the current, we have to add meters that are set up to measure current. And you've already learned that to measure current, you must break the circuit, essentially break this connection here, and put the meter there. Same thing, I'm going to break the circuit between these two LEDs and set in a meter, and one more between these two LEDs to show that the current is the same everywhere in the circuit. And here's the circuit diagram showing what that looks like with the meters in place. Each of these diagrams is one of the meters set up to measure current. A is for amps, or ammeter. Okay, and here's the setup. You can see that we have a meter set up to measure the input voltage. We've got 7 volts applied, and that's applied across R1, this resistor, and 3 different LEDs, green, red, and yellow. And you can see the meters are all reading basically 8.6 milliamps of current. Now you might wonder, well, this one says 8.63, this one says 8.60. That is meter error. These meters are not perfect, and so they aren't exactly accurate, and there's a good indication right there. We know in theory that we should see the same exact number. This just shows a little bit of variance between the two meters. So essentially we have the same current everywhere in this circuit. Watch the input voltage. I'm going to increase that voltage. You'll see the voltage go up. What should happen to current? An increase in voltage results in an increase in current. Voltage and current directly proportional. And if you can see in the video, the LEDs got a little bit brighter because as the LEDs get more current, they give off more light. Well, what happens if you have a break in a series circuit, or in other words, an open? Does current flow from the voltage supply and go as far as each LED? If there's a break right here, will we still get current through L3? Well, I hope you know that the answer to that is no. A break in a series circuit results in no current, and no current anywhere in the circuit. Well, let's watch that happen. Here the circuit's operating normally, and I'm actually going to cut the lead of this red LED. And watch what happens to current. Notice that there is 0 current everywhere, and yet the applied voltage is still at 9 volts. So you can still have voltage, but no current. That exists all the time when you don't plug something into your AC wall outlet. The voltage is always there, but you haven't plugged anything in, so there is no current being used. Same thing here with 0 current because of the open in the circuit.